Okay, so, attention please. Alright, so today we're going to use the chain rule to differentiate functions that include e, or basically just, exponential functions. So, first thing I would like to know, who remembers what the chain rule is? Max?
Do normally?
Ooh, no, that's product rule. Alright, Max.
So you got the brackets, so you do what's like outside the brackets, so
Yep.
you put the front of the power and you do by two, and you add the first derivative of what's inside.
Oh, sorry. So, yep. Okay, so that probably looks like mumbo jumbo to you, but what that means is, let's change colour. So, power down the front. And we have our original equation. Minus power by 1. And multiply that by the difference. Alright, so we're happy with that. So, alright. Alright, let's get back to this. So we're going to use this rule. It is the same thing, but here we have our function. Okay? So what do you think we're going to have if this is our function? This is essentially what's in the brackets. So usually what we do is take this down, write the equation again, minus the power by 1. We're going to do a similar thing. We're going to just look at e to the power of something. So what's e to the power of x differentiated? So I'm literally going to write the same thing again. Okay? So this is e to the function of x, but when I differentiate e, I usually end up with e to the x is e to the x. So then I need to multiply that by the differentiation of what's in the brackets. So what's that? Up here, it's f dash of x. Okay? So we're just going to differentiate what's in the power and times it by the identical thing again. Yeah? So, let's do an example. So here, we've got e. What's our function? What's it to the power of? Can we read that? Yep. So, here, if I follow this, I like actually doing these the other way around because I'm a bit pedantic with how I write things. So, we're going to differentiate what's in the brackets to begin with. So, what is 5x minus 2 differentiated? 5. And then I write, done. Yeah? Because f dash of x is 5. I should probably write the function first. So the function of x is 5x minus 2. F dash of x is 5. Yeah? So we just take what we had before times by 5. Yeah? Do you feel okay with this so far? Alright, let's look at the next one. This one integrates product rule and chain rule all in the one go. Okay? So, what's up, Angus? Yep. Wait, what? Okay. Yep. So this here is the differentiation of the function. The 5. I just put them the other way around because otherwise I have e 5x to the power of 5x minus 2 times 5, and I don't like writing times if I don't have to. I'm quite lazy in that. No? This is just normal. So if I had this function here, 5x minus 2, that differentiated is 5. Okay? Yeah, so that's where it's confusing because e to the x differentiated, like we did yesterday, is e to the x. That's why, so I did differentiate e, but it's exactly the same. That's why this makes this a bit confusing. Yeah. Yes. Okay, so this next one, I've got my u. What is my u? In this equation here, I've got a product rule. X squared. What is my v? Okay, so this u, we know what to do. What's u dash? Alright, v dash. This is where we're using that rule again. So, I have my function. That's 3x. What is the differentiation of 3x? So I've got the 3, and then I write e to the 3x. Now I can do the rest of what I need to. I'll do that in red. So, product rule is vu dash plus uv dash, or either. You can switch them the other way around. That is also equivalent to uv dash plus vu dash, however you want to do it. Just match that with that, that with that, and add them. Okay? So, here we have 3 e to the 3x x squared. That, I connected those two. And I've got that with 2x times e to the 3x. That's an ugly 2. Yeah? So, I can literally leave it like that. I'll make it so it does this because, I don't know, I'd like it nicer. Yeah, sorry. That better? Yeah? So all I did for that second line was whack that in the middle there because I think it looks nicer. If you think it looks nicer the other way, that's fine. They're the same thing. Soz. I just have a way of writing things and I just find it hard to break from it. Yeah? But we're cool with that? Alright. So, next thing it says, given y equals 2e to the power of 3x plus 1, show that the second derivative equals this. You can, but they're the same thing anyway. I'm not going to make it any simpler if I factorise something out. Yeah, but they're stupid. Alright, so just note that this is the second derivative. Who knows what the first derivative one looks like? In this form. So the first derivative is dy dx. The second derivative is d squared y over dx squared. So whenever you see that, note that it is the second derivative. So we need to differentiate this. So let's go for it. Y dash. So the 2, who cares about it? Let's write it again. We've got e to the 3x. Did we not just differentiate that in the question above? Yeah. So what is it differentiated? So we differentiate the 3x and we get 3. And then we write the equation again. Okay? And the 1 disappears. Yes. So, if I simplify that, that is 6e to the 3x. Alright? So, let's... Interesting. Have I forgotten something? No, I haven't. Okay. So, y double dash. So, let's do this again. 6 just chills out the front. What do I have now? What's e to the power of 3x? We differentiate 3x, we get 3, and we write it again. Now, have I answered the question? No. So there's something peculiar in here. What's y?
2e to the 3x plus 1.
Yeah, that's our original function. My pen wants to work. No! Oh, there it goes. I think my battery's going dead. Okay, so what I'm actually going to do is I'm going to put the original function in that and see if I can either get to this or manipulate this to see if I can get to the other thing. So this is saying d squared y over dx squared equals 9 bracket, my original function. So that is 2e to the 3x plus 1 minus 1. So whenever it says show, you can either show that the left-hand side equals the right-hand side or just manipulate one side so it is the other side. For this question, I find this easier because it's got the plus 1, minus 1 mumbo jumbo. So really, that I can just take those brackets away and we have 9 plus 1 minus 1. What's plus 1 minus 1?
0.
Yeah, so we have 9 times 2e to the 3x. What's 9 times 2e to the 3x? Perfect. So, therefore, left-hand side, or you can see therefore that equals that. So this one here equals that here. You can see that they're the same thing. Okay? That's all that question's asking you to do. There was one at the end of the exercise yesterday. Isabel got up to it, and she found that she didn't understand what was asking because of that wording. So that's why I put that one in there. No, definitely not. And if I did, I probably may not get that great marks. I do better than when I was in high school.